So what we are going to do now is we will have a panel discussion with our experts. All of them are members of the Automotive Edge Computing Consortium. And I'll get my notes, and then we will get started with the panel. Great. I'll get my water. Okay, so maybe we can start with an introduction. So Muriel, can you tell more about what you do, your company, and what's your role?
Okay, so my name, you could see it, Muriel. I'm working 27 years for Toyota, which is quite a long time. Being always in charge of looking what is coming ahead of us, core technology or also societal changes. So I'm responsible to detect this technology, and once they are detected and approved, I'm testing them so that while we confirm the validity and really the opportunity for us, we will bring it in operation in the vehicle we are constructing. In that sense, we detect already for a while ago the potential of the 5G, the breakthrough that 5G can bring, and that's why we work on edge in this case and also on real-time big data to see how we can improve our vehicle by using this technology.
Bruno, what about you?
So I'm the co-founder and CEO of Nexar. Nexar is an 8-year-old startup. What we do is, our vision is we want to move as one. What that means is we want that when I drive, what I see as I drive, I share it with others around me so that they can benefit from that intelligence and we can cooperatively be safer. And the way that we do it is we deploy eyes, cameras on the road, either our own cameras or somebody else's cameras. Those cameras with AI, they're able to share with each other that intelligence and create a live map of the world and all the way to an HD map of the world that is updated in real time as you drive.
Great. Yoshi, KDDI.
Yes, I'm Yoshinori from KDDI. KDDI is a Japanese telecommunication carriers, and my job is exploring the use case of the connected cars and advancing the development of the out-car communications that realize the that make it easier to realize the use cases, and also developing the business with using those use cases. Yes, nice to meet you all.
Great. Couple of information for the audience. As I said earlier, you will be able to ask questions to our experts after the panel in the last 10 minutes. But also, I want to make sure that the audio is okay. Can everyone hear us? Okay, great. Okay, so let's get started. So we saw from some of the earlier slides that the connected vehicle market is growing significantly. So thinking about connected vehicles, why is the use of networks and cloud and edge, but also the integration of the two, more important than ever before? Maybe Muriel, we can start with you.
There is really a change happening in the sense that the fact that the car can be connected open the doors to millions, or not millions, but a large amount of application. But most of them require a lot of data, and having the data going to the cloud and not on a local place might be not cost effective for us. And maybe also we may lose a bit the control of privacy in that situation. So in that sense, having edge is critical for us. And at the same time, a car, as we know, is driving all over. So in that sense, some information are needed only locally. Somebody in Spain no need to know what is happening in Belgium. So this local aspect is super important. And again, the edge provides a solution for this.
And Bruno, what's your view?
So I think applications like automotive should be the key application that a telco should be focusing on right now. The cars that existed 10 years ago, there were single-player cars. You just get into the car, put the keys in, and you can drive. Nowadays, to drive safely, as we see what is called level 2, level 3 automation in the vehicles, you don't want the car to be the last one that knows. So you have not just my telemetry data, which is insignificant, but these sensors that exist in the car that are megabits per second or gigabits per second that are generating intelligence that will be useful for everybody around it. And that's critical to share, because otherwise we are not going to reach that level of automation and safety on the roads that everybody desires, from the consumer to the regulator to the manufacturer.
So Yoshi, KDDI is one of the largest operators in the world, one of the most innovative. Why mobile networks are important for connected cars?
Yes. For example, data that's, for example, maintained the cars. That is very important, I think, at this moment, because let's think about Tesla. They have proven that car can be updated. That means software in the car is updated many times a month, and they know that the current vehicle status and also characterize the behavior of the software, current version softwares. And also that is used for the understanding the poor behavior of any functions, or including a new functions to the cars. That's why even current car, how can I say, automakers, they think the communication is important, I think, yes.
Great. So let's now go deeper on the network infrastructure discussions. So the connected vehicle service market will transfer huge amounts of data to the edge cloud each month. It's way, way more than what current networks can manage. So this means that building a fit-for-purpose network infrastructure is super important. So Muriel, I wanted to ask you, so telecoms operators are currently deploying 5G networks, including 5G standalone networks. What should operators do more to drive edge deployments and in automotive? And beyond operators, who should contribute to making such investments?
Mm-hmm. I think that, as I mentioned, the benefit of all this new service will be for a lot of industry and also for cities as well. So I think that the job that operator is doing is good, because we have regular contact with them, we understand each other, we understand that our business model are maybe not the same, that our priorities are not the same. We are, of course, as you know, very much safety and reliability oriented, which is quite different from a consumer aspect. So we are doing good job with operator, and that's important that we continue to understand each other, but also it's important to bring all the other players of this ecosystem, because the others have also knowledge on AI, knowledge on the way regulator can be approached, knowledge about how a country is moving. So what I want to say is that we need to continue with operator, but it's very important that we enlarge to all players, because all of them will have a critical elements in this. And related to investment, that will be a rolling ball of all this industry to be able to provide the services.
And obviously the value chain is big, so it's important that all players play a role through partnerships. So partnerships are becoming very critical, important, yes, to drive developments. So one of the findings from our research is that when you ask operators, what's your greatest challenge today for deploying edge networking, they say the greatest challenge is uncertainty in terms of return on investment. So Bruno, and the same could apply to other companies, not only operators. So in your opinion, which edge use cases for automotive have the potential to change this, thus accelerating the build-up of edge infrastructure?
Yeah, I think it is the critical question, and you were showing earlier in the introduction a chart with the use cases. We believe driving is the use case that will push it, because driving with ADAS assisted systems or driving with autonomous systems basically gives not just safety, which consumers greatly decide. There's a lot of surveys that basically consumers want more safety than just what the car can provide in terms of a better structure of the car, but also provides comfort, right? If you any here have driven a Tesla, you will get that there is a feeling of relief and comfort when you basically are engaged, because you kind of, it's like when Waze appear, I'm delegating my guilt about being late to Waze. Now there's a little bit of, when I drive an autonomous vehicle, I'm delegating to the vehicle to basically take care of things, so it's more comfortable to drive. The issue is that to drive safer, you don't want the car to be the last one to realize that the environment in which they drive has changed. And why? Because these are mission critical systems. And if the radar fails, if the cameras fails, if everything fails in the car is blind, and the driver needs to back control. So the theory today is like, let's give everything we can to the car to make the car be safe and comfortable. How does that work? By getting data into the car. It's no longer about how do I drive on myself, but can I get more data about the things happening around me as they happen? For that to happen, that's the download. The internet is well designed for that. That's the CDN approach that we know. But for that to happen, all the cars around me, they need to upload. And the issue is that that's where the internet wasn't designed for that. And there was a release just a few days ago with Mercedes and NVIDIA that they announced that they were deploying the Orin into Mercedes-Benz. The Orin chipset from NVIDIA is 8 times more powerful that the Xavier was, and that was just released 3-4 years ago, the first generation of the platform. So on 3-4 years of timelines, we exploded the compute in the car by 8. The networks, the fiber required to go to the cloud cannot scale by 8 times in 4 years. It's just, there's not enough money, right? Forget about the 1.3 trillion.
Yeah,
It's just like the GDP of a bunch of countries to do that.
Yes.
So the only way to do this is to do it at the edge itself. Right, the data stays close to the car, it stays back at the metropolitan level. You don't need to backhaul back to the core of the internet, and you bring back, and that's how you close the loop and you deliver on the promise of safety and comfort to the users.
And Yoshi, what's your perspective as an operator? How can we make the return on investment more visible for operators?
Yes, I'm expect to the video. Actually, video processing is the important part, and everybody expect that edge computing is needed, because when we think about the dashboard camera videos, currently that's correct image on the memories of the dashboard camera. But because in Japan case, everybody takes the dashboard camera, probably automotive makers will build the camera into their cars. In that case, let's think about some car accident. Sometimes the stored data, video, may be damaged. In that case, video should be kept out, even in for a short period of the time. In that case, the edge computing site, storing site, may be important for proof that what happening in the car accident, but it is not always needed. So that data should be erased after a few minutes. That's why I think that kind of a video will help us to everybody to think the edge computing site is needed. Yes, thank you.
And so you mentioned the data, and so we have talked about the network infrastructure that is needed. from mobile networks to edge computing. Let's now talk about the data opportunity. So these connected cars are generating and will generate huge amounts of data, and this can only grow because new services are scaling, HD mapping, intelligent driving, mobility services. So huge amount of data. How do we monetize it? How do we turn this data traffic growth into an opportunity, a business opportunity? And maybe if you can mention some examples of services that are already monetizing the data. So I will ask these questions to all of you. So Yoshi, maybe we can start with you.
Yes, I think vehicle data, some kind of orchestration that helps for the creating a business opportunities. The reason is that, for example, car status is collected, and that means the data is collected at the cloud once. But actually, those data may include the unused case. So in that case, telecommunication carrier thinks those data doesn't flow to our network actually. So when I think that we need a edge computing site collecting the data and pick up the important or needed data. And also, when we imagine the maybe extreme images, we may prepare the many edge computing or edge data site could be implemented. For example, petrol stations. Currently, petrol stations, but it will replace to the charging spot, I think. So in that case, the charging spot can house the high performance computing, not so many, but small. And it can store the data or do some computations. And in that case, the carrier takes many edge computing sites, then thinks about the how we optimize the storing the data. And also, currently, carbon zero is important. Right. So when we think the carbon zero, thinking into that, optimizations, the data may be prepared, stored in how maximize the carbon zero use case of the energy consumer. So in that case, important things is preparing the many edge computing site and thinking about the carbon zero, and also thinking about the behavior change of the persons, drivers, because collecting data to the carbon zero site. This is a very far futures idea, but that's kind of ecosystem combination of the players can be important, I think. Yes, thank you.
Thank you. Bruno, what do you think?
So I concur very much with the message from Yoshinori-san. I think in addition to that, there is an opportunity right now for the telcos and people close to the telcos to monetize the data in new exciting ways. The cloud providers like Amazon and Google have had a monopoly on compute for a long time and compute resources due to the high density and low cost of data centers and a lease model on real estate. But now suddenly we're realizing, well, maybe I don't need to move those workloads anymore to the core of the internet, which is expensive because the fiber outlay out front that I need to do. So it creates an opportunity to bring those, what's now really containerized workloads that are very portable and very elastic in terms of how they move, close to those multi-edge compute locations, and be able to run these computer vision applications very close to the car without having to go to big data farms. I think personally what that's going to create is it's a new ecosystem of data center providers that exist at the metropolitan level they will offer much more competitive rates than the cloud providers do, and we'll see a specialization between people who are more real-time type of workloads, more analysis type of workloads that are real-time, and people who specialize more on amassing huge amount of data for processing analytics and things like Netflix streaming back to the people. Yes, the source encoding of the videos, it's on the cloud on AWS, but then you push it to a CDN for reading. So what exists today a little bit with the likes of Fastly, I think it will start to expand to more players that in conjunction with the telco will create a new ecosystem of
It's interesting to see that the progress with technology is opening up the market to new players. And this happens not only for edge, but also for private networks and other technologies. So it's an ecosystem that is expanding more and more. And Muriel, what's your perspective on this?
The prospecting on monetization, you see, at the beginning we were thinking, okay, we can sell the data and we will make money. No, of course, this is simple. But at the end of the day, if everybody has data, the value of the data will decrease because it becomes a commodity. In that sense, in our case, from the beginning, we thought, okay, let's use the data for our own business to increase the efficiency of our business. How can we develop car much faster, especially when it's a car that we don't have a lot of experience? Having the usage of the car on a real time help us to see if we design well that car so we can improve it better. And in that sense, it's about monetization by internal efficiency and by also developing new type of cars that, for example, can recognize it's you or me driving, therefore I prefer this or this. So you see, turning really completely back to us rather than to sell, although we wanted to sell, it's not a problem, but we think there is less value there. And I think it's also in the EU mindset. You may be familiar with the project Gaia X or Catena X, where Europe said, okay, we cannot beat the GAFA, well, it's US, so we are not good at this, but let's take care of sharing data for small, medium enterprise, which is the major part of Europe, and share this for the efficiency of each and every industry. And I think that's the way we need to continue to move on, because there where we, I think, have the highest potential.
And I'm glad that you are saying this, because it confirms one of the findings from our research. My slide, when we asked a number of automotive enterprise, why are you accelerating digital transformation? Half of them said cost efficiencies. Half said new revenue opportunities, new business. So equally important, efficiencies and new business.
Of course, yes.
Okay, so we have talked about the network infrastructure, huge amount of data opportunity. So beyond building a fit-for-purpose infrastructure, what else is needed at ecosystem level over the next couple of years to scale edge technology in automotive? And Muriel, maybe we start with you.
I think what we need is to continue to work on standardization, because that's super important. You see how many of us are involved in this. If we cannot speak the same language, it will be a mess. So standardization is key, as well as some regulation alignment. As you know, we drive, or you drive the car all over in the countries. If the regulations are not the same, how can we provide a continuous service? So in that sense, having the government also more involved in the discussion so that we have a common approach to develop all these services, that's something that we are really need to consider from now on. Even though standardization is already on the way.
On the way, yeah.
That's the point, but continue to go there and to go beyond what we are doing now, because, again, involving all the partners.
Taking standardization to the next level.
Exactly.
To be fit for purpose for deployments. Bruno, what do you think?
I've been thinking about this for quite a while. There's one thing that I think we've been proponents for a long time, which was, regulate about the use case, don't regulate about the technology itself.
Right.
There is one thing here right now that I think, in my opinion, is really getting on the way of how we work, and that's net neutrality. Net neutrality is forcing that if I am in the car, the level of service for watching a movie from Netflix is the same as downloading an HD map at that time. Also, if I'm sending a message to WhatsApp, that message needs to go back to the cloud servers of WhatsApp and being routed. And that costs way more because it has to be routed on fiber than it costs if some message just stays within that radio tower or close to the radio tower. So I think, in my opinion, that has to change. We need to accept that there have to be different levels of service. Part of that comes through spectrum and making available spectrum that automakers can benefit, and that is for certain use cases. And there is a big danger here in abuse, right? We tried this before, and what was supposed to be a safety spectrum became something completely different for advertising for whatever reasons, right? So I think they need to regulate, the same as surgery in a room. Like, you don't expect that 5G connection to the surgeon in the middle of Africa to also be used to send an ad. So I think for automotive use cases, we need to think the same, is how do we prioritize use cases that are truly generating value, that are making the road safer, and not get them abused, make more spectrum available, and follow some of the leads that in the US, for example, there is with CBRS, the citizen band, where the cities realized, well, we need to let the Verizon and the AT&Ts come here to use the poles to put their antennas for 5G. Why don't I, at the same time, deploy a public infrastructure for CBRS and make Band 48 available to the public? So I think Europe, for example, and Asia need to start looking at that. And they're starting to look at it, right? But that's a key part of that, what I call the net neutrality problem. You need to step away from this whole concept that routing a message to WhatsApp and Google is the same as a doctor doing surgery.
So standardization, spectrum, regulation of use cases, net neutrality. Yoshi, what else needs to be done at ecosystem level?
I'm also the same. Probably the regulation works well. Autonomous driving will start probably, in 2 years. Japan thinks so that. And also, that's autonomous driving needs remote monitoring. That's the police agency of Japan show the guidelines. We need monitoring, and probably remote driving may help if the autonomous driving car has a problem, and it should be moved. So those are how can I say, regulations helps to the increasing the data, and also we need edge computing side. I think I expect that. Yes, thank you.
Okay, so we will be ready for questions in a couple of minutes. I have a really final question to all of you. Let's make a prediction about edge computing for automotive in 2023, or maybe something that you are looking forward to. Muriel, we can start with you.
What is critical for us for the moment is seamless connectivity, because we wanted to provide to the driver no problem all over the roads. That's critical for us, and that's a priority, as well as to work on the service resilience. What do we need at what time, and how to secure that this resilience for that specific service is established and continuously there. So these are the two critical elements, I would say, for the coming months or years.
Bruno.
I think in 2023, what I would like to see, and I think we're very, very close, is, as I mentioned earlier, moving cloud workloads already today, right, to things that are running on little data centers close to the cars. And I think the main thing that we're going to see there is Kubernetes as a technology coming into the car itself and to the edge with things like K3S, gaining a lot of traction. And I think this is happening this year. This is not, it's not an AV thing in 5 years from now. We're already starting to see it through Equinix and Vapor that are deploying in data centers, but this is becoming available through their partners.
Okay. Yoshi?
Yes, I'm simply, I expect that charging spot, increasing the charging spot. Probably that is the first step for the cars correct data is collected from the cars, and it leads to the edge computing side. We think so. I expect the increasing the charging spot. Yes, thank you.
Right. Okay, we are now ready for questions. I think we have a couple of microphones. So any questions for our industry experts? We have a question over there. If you can say, please, your name and company.
I'm Juan Ruzafa. I'm telecom engineer, and I act as an independent consultant. Okay, so this question is for Bruno. The edge computing, okay, but why not the edge could be the car? What, do you see this point in the future?
Yes.
Very good question. So the cars today, like as I mentioned, the Orin platform has 250 tops, which is good for doing the mission control and analyzing what's on the road. But what you see has a bias. There might be something in front of you that is blocking the road and you don't see the traffic sign. So the need to collaborate between agents is going to exist. In the past, this has been tried with vehicle-to-vehicle communication. And the issue with that is one around trust, is one around context, one around security, one around privacy. We have now this metropolitan level or a tower level, if you want, right? Depends how you deploy it, that allows within single-digit millisecond to provide that aggregation of the data. So it's no longer a many-to-many relationship. It's a many-to-one and one-to-many in a broadcast level. So it's more efficient from a broadcast level. It's more efficient from a compute perspective. You're not forced anymore to have 1,000 tops in the car because 700 of those can be in the share between all the cars. Why? Because of the same thing. The car is only used 5 to 7% of the time. So I think there is a good reason why the cars will never be able to do that. And that's mostly economical. It just does not make sense to put a data center in the car when it's cheaper to put it shared between people.
Yes, but think about the power of the chips, okay? So if you can compute on the car, then you after need to send less info to the edge, okay? So my question is to introduce this
totally
point.
peace. I think everything that should be feasible in the car should be done in the car. Because also the amortization of that hardware is much better than on shared infrastructure. But as I said, there is a limit to that when you go above it, because if you put the most expensive Xavier platform that NVIDIA did, would increase the bill of materials by thousands of dollars in the car, and then you don't have a profit, right? So there is a limit in terms of what's possible and what's financially possible.
Okay, thank you very much.
Thank you. Any more questions? Oh, we have a question over there.
Hello everyone, I am Abhishek from Airlink. So my question is from Muriel. So right now connected cars is picking up and there are a lot of old cars which are not connected. So when we have this edge computing, then what will happen to those old cars? Will we have some retrofit device or they will never be a part of edge computing?
Well, maybe I can reply. So indeed, that's a very big question, and that's a question we are facing for each change of technologies. That's for sure. But it's for sure as well that having the car, we can retrofit, but we can also use the device of the consumer in the car to provide some information. So to some extent, we need to see in this transition phase how other IoT in the car can support and make a flow or a smooth transition to what we wanted to achieve. But this is a typical problem that we face. Also, for example, we have hybrid car or electrical or fuel cell, how to manage all this at the same time so that it's easy for each and every customer. So this transition, we are working on it, yes.
Okay, so you also talked about standard protocol for this edge computing. So why we are not having the standard protocols between hybrid cars, electric cars, and every time we have to have this shift in the technology?
Again, we need to have a standardization on the communication, but we cannot do a standardization or a regulation on the technology, because then we are not in a free market, if I can say like this, or as well, we cannot serve the needs of each and every customer. One electrical car is super nice, but maybe not for your need, but maybe for my needs. So in that sense, we speak about standardization, but on communication in this case, rather than on the technologies, because that's where we can also be the most creative to provide the best service to each and every of you, of us as citizens.
And if I may add to that, I think openness and interoperability doesn't actually mean that you need to retrofit it, because if the use case that the new specification, new technology opens, you will find aftermarket solutions through mobile phones or whatever it is, that as long as it's interoperable, a hybrid car will adopt it, and an old diesel from 1998 will adopt it.
Correct.
Because consumers want it. If the application is not good enough for the consumer to want it, then no, there won't be any aftermarket solution. So I think that's where a free market really will come into place to fix that problem.
Thank you.
Software will be very, very, very important. Any more questions? We have one over there.
Hi, Lena Rodziewicz, Mobica Limited. I'm software solution architect for connected devices. So my question is still along the lines of the cars that are not connected. So where do you see the threshold where the security, the safety increase on the street when the amount of cars that are connected increase the overall safety on the road? Where is that threshold? How many of these have to be connected?
Interesting question.
It's
Anyone?
an interesting question, and of course you can see it from the customer, so he or she can have a safety environment, and I would say threshold there is 0 or 1. As soon as one customer can have more safety, it's okay. Then we speak about a more macroscopic, how a city can improve the safety, how a country can improve the safety. And that's, of course, much different. Of course, it's difficult for me to give an exact number, but from our viewpoint, as soon as one car is more safe, we are on the good way. So that's what we can do. From the city or from another macro perspective will depend on their priorities as well. But of course, that's what we can discuss with them as well. But sorry, it's difficult for me to give then, from that aspect, a number, but anyway we go.
I can give you a number, actually. So we have 500,000 vehicles, a bit over 500,000, 700,000 that we sold over history. There are a few hundred thousands in the US, and those vehicles right now, right, we're the largest connected network exists in the world through mobile phones and cameras. There's nothing in the car yet. And those vehicles are generating real-time data about traffic signs, about congestion, about roadworks that are blocking the road, and anybody can benefit from that. So a very low percentage of penetration in the United States of 240 million vehicles, which is what we have, is already generating, for example, in Manhattan, data every few seconds on every road segment. Why? Because of the way that people drive, their patterns, their random roads. We also did a study when we started the company that with 3 to 5% you enter a phase transition, that you start to see very, very quick returns on investment. So we don't need, this is not like the classic V2B use cases that you need it 100%. You can start adding value today already for single-digit percentage on the penetration.
Okay, thank you.
And I guess also the correlation between number of connected cars and the safety impact is not linear. So you say if you double the number of connected cars, you are more than doubling the value in terms of safety, because it's is the combination of these connected cars and
It's a
how-
phase transition. It's like
Exactly,
water
yeah.
boils from
Exactly.
liquid to gas, right? So this is the same. There is a level of adoption that unlocks a use case. Each use case has a different threshold for adoption, but some of the use cases, like headway collision, it's a very low, a single digit, right? And that what makes it really exciting as a technology. Now, if you go very complex things like intersection movement assist, then yes, you need a much higher percentage of adoption to be able to do it. But it literally is a phase transition. That is no value, no value, no value, and suddenly with just another 1% increase, suddenly you unlock the use case.
I think we have time for a final question from the audience, if any. No more questions? Okay, so thank you very much, Muriel, Bruno, and Yoshi. It was a really good discussion. And also, I would like to say thanks again to the Automotive Edge Computing Consortium for sponsoring this conference. I hope that all of you found this interaction and engagement useful for your activities.